Okay, so we are going to start with our chem review on topic 1, section 1 on page 2, the overview of the atom. So atoms were first, the idea of an atom was first come up with by the ancient Greeks. So you do need to know that. I will show you what I have highlighted in my review book as kind of notes so you know what you need to highlight. So the ancient Greeks were the first ones that kind of came up with the idea that there was an atom. Then nothing happened for about 2,000 years, and then John Dalton came up with his theory of an atom. And he had a couple things too. He said all elements are going to be the same. If they're different elements, they're going to be different. Atoms are indivisible, and they can come together to form compounds. And then we find out that some of that's not true because later we have a scientist, J.J. Thomson, who discovers the electron. So he discovers the electron, which is a big deal, and he thought that the model of the atom had these negative charges, and then everything else was positive. So everything else is just kind of this positive, goofy soup, sometimes referred to as the plum pudding model, where the pudding is positive and then the plums were negative, also referred to as the chocolate chip cookie model, where the chocolate chips are the electrons and then the cookie dough is the positive part. Because we know that atoms are neutral, so if there's negatives, there also has to be some kind of positive. And then after that, the next person that did some work was Ernest Rutherford. And he has a pretty famous experiment. He has the gold foil experiment. So what he did, so I'm going to pull up the review book because the review book has a really, really good image. So as you can see here, he has a source of alpha particles being shot at a very thin piece of gold foil, and then he wrapped it with photo paper. And alpha particles have energy, so when they hit the photo paper, it causes it to come up with little blips. And he found, as it shows, that these alpha particles were deflected and hitting all around, although most of them went straight through to the other side. A bunch of them went around. So this led to a couple conclusions. One, that atoms must be mostly empty space, since most of the particles went through. And two, that they hit something. And since alpha particles are positive, whatever they hit must have also been positive because it deflected them. And that's where this image comes in, because this image shows your atoms, and it shows most of the alpha particles going straight through, but then them hitting a very small, dense, positive nucleus. So his two conclusions were atoms are mostly empty space with a positive, dense nucleus. And then we fast forward a little bit more, and then we have Niels Bohr, who comes up with the idea that, well, we have these protons, we have this nucleus, we have electrons, and they must be in these fixed orbitals. And he has the positive nucleus and then electrons moving around in orbitals. And this was a pretty good model because it explained that these electrons are moving around and why they don't get sucked right into the nucleus. However, though, and the outermost shell are called valence electrons. And these we found using your reference table. They're the electrons in the last shell. These orbitals are also referred to as energy levels. So this would be the lowest energy level. This would be a higher energy level. And every time you add an energy level, that has more energy. So if I had an electron in this energy level, this electron has more energy than an electron closer to the middle. And then the last thing we have to talk about is called the wave mechanical model. And the wave mechanical model is the most probable location of an electron because they're moving around really fast. And since they're spinning around, we don't always know where they are. Sometimes they're further away, sometimes they're closer. So this is the most likelihood of finding them, and that's what's called an orbital. So I'm just going to quickly show you what I have highlighted in my review book. So as you can see, as you go through, I have a couple things. I have a couple notes. I hope you can see that. The next page, so again, I have a couple notes, what I have highlighted, and then over to the last page, and my notes are here that they're not always there, but they are usually there for our orbitals. So that is going to conclude our very first topic 1, unit 1.